My name is Bjorn, you might know me. If you have ever worked with Prometheus, or you're my neighbor or something. Hello. This is new. I'm starting to work for a company called Grafana Labs, or Grafana, whatever, last week. So, yay. The first time that I create a slide with their logo, and I butchered it by putting the Prometheus logo. That's kind of nice, right? All right, alerting on SLOs like pros, that's a blast from the past because that's something I worked on while still at SoundCloud. It was all a graceful transition, so I'm still allowed to talk about this, and it's all fine. But this is also, it was framed by certain people as the SLO, SLI, something theme or talk. There are blue books, our holy scriptures, right? Blue books, first SRE book, second SRE book, SRE workbook, and then the Seeking SRE book, aka SRE for Mere Mortals. They are all important, perhaps you've read them already. There are a number of really important chapters. This is chapter 6. They are all, the first two are online, you can just read them as HTML versions. Chapter 6 is kind of the talk about how Google is doing monitoring. This is all based on a Google doc from years ago that went viral. It's called My Alerting Philosophy by Rob Evershoek, somebody I worked with while I was in Ireland. Like all the important people worked with me while I was in Ireland, somehow. So this is written, it's really nice, and it's essentially the philosophy behind Prometheus as well. And I mean, Prometheus is not mentioned here, but this is kind of exactly the spiritual background or the basis on which Prometheus was built. So super important. Then there is chapter 4, again in the original SRE book. That's service level objectives, just essentially what we just learned, the general thing. Very important for the theme as well. And chapter 10 is the most famous or infamous chapter because that explains a monitoring system called Borgmon in quite some detail. It's called Practical Alerting from Time Series Data, but perhaps you have heard about it. Prometheus is kind of made with the same semantics in mind than Borgmon, which was back then something that nobody knew about. But Jamie Wilkerson was always really keen on talking about it. And I mean, little anecdote, when Prometheus came out, he said, oh, finally I can talk about this. And then he gave a talk at Monitorama where he was talking about Borgmon, but pretended he's talking about Prometheus. And then like 30% were wrong because Prometheus is actually not Borgmon, but anyway, he glossed over those details. This is really interesting because it explains Borgmon, but you cannot try that out at home, right? And he even writes that, but how does that help you, our dear reader? And then in recent years, we are talking about the year 2016, monitoring has undergone a Cambrian explosion. Riemann, Hacker, Boson, and Prometheus have emerged as open source tools, blah, 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 blah. Prometheus shares many similarities with Borgmon, especially when you compare the two rule languages. And then the principles of variable collection, blah, 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 blah. Like here, we get the special shout out. And also we should note that I think Hacker had its last release December 2015. It's more or less dead in the water. Boson was abandoned by a static change, and one of their founders is now working for Grafana, by the way. I think Riemann is still doing well, right? But whatever, you see who won, right? I mean, there are way more tools by now, but back then, that was the mix. And also, this is the chapter where this infamous sentence came from. Even though Borgmon remains internal at Google, the idea of treating time series data as a data source for generating alerts is now accessible to everyone through those open sources like Prometheus, Hacker, Boson, and Riemann. So this was elided here by Julius. He's now not here, but I would not have done that, right? It's so mean, and it's still on the webpage. Anyway, so Prometheus law, this is where it's coming from. Okay, so now, the book. This talk is essentially just a, guided reading of chapter 5, Alerting on SLOs. So the workbook was published because many people said this Google SRE book is great, but how does that apply to me, right? So people wanted more practical recipes. They also wanted to see application outside of Google scale or the Google context. So this is also the reason why Seeking SRE was written, because this is written by non-Google organizations who did SRE in one way or the other, among others, SoundCloud. And the workbook is kind of written where Google said, we will give you all the recipes. And one of the recipes is this chapter 5, alerting on SLOs. And there we are, this is the overarching theme here, right? So I also wrote a blog post. You could see this doesn't work here, right? I point. June 4th. So this was when I was already working for Grafana, and I would still publish it under the SoundCloud banner here, whatever. This is the SoundCloud backstage blog, developer blog of SoundCloud. So in principle, you could just go home now. I mean, we have still bagels, but this is, if you read this blog post and read the chapter, that's kind of all. It's just the live action show, live action version of that talk. Okay, so before we go into the recipe part, I mean, especially I want to emphasize the things that are slightly different from the chapter 5, but I also want to go into some basics. And the one is from the famous chapter 6, the philosophy chapter, if you want, symptoms versus causes. What versus why is one of the most important distinctions in writing good monitoring with maximum signal and minimum noise. And that's this wisdom that like became really like viral and popular, that you should wake people up if you have symptoms, not causes. And it's kind of, at least back then, this was fighting an intuition where people thought, if something breaks, like a server is down, a hard disk breaks, I should wake somebody up because something is broken. And people, yeah, it was kind of complicated for them to understand that now we have systems that actually can tolerate failure, and they must tolerate failure because failures happen all the time. And they had to see that you couldn't just alert on a hard disk being down or a server being down. And there are also like funny examples. This is just copied directly from the book. Like an Ethernet cable is crimped under rack, visible as partial packet loss. And that happens all the time, right? Ethernet cable. So, but there's also another thing here. It's tempting to alert on causes, but it's also incomplete, because causes, the most interesting / most devastating outages are caused by problems that you haven't foreseen. That's why they're so interesting and devastating. So you probably don't have an alert for that. You never thought about this Ethernet cable being crimped under rack, so you have no alert on it. I mean, perhaps you have an alert for packet loss, of course, right? But you get the message, right? It's like causes are not only noisy, as they might not actually cause an outage, but they're also unpredictable. Well, symptoms are actually really predictable. Symptom is my users are happy. So some people even put like watches on Twitter. So if people, like Google had this, if people tweeted Google is down, then the search team gets a page, right? SoundCloud still has this, at least in their like postmodern process, that you always look how many tweets did we have, and also the community team would page engineers if they see people are tweeting about it and nobody internally knows it, which happens rarely because you have an awesome monitoring system. Yeah, so, and now symptoms, what are symptoms? Symptoms is essentially you are not fulfilling your SLO. And that's why this is all connected to SLO. In the ideal case, your SLO defines if your site is up and down, and then you just alert on you are not within SLO. If I say alert, I probably mean pages. The terminology is a bit screwed up. That is partially because I think in the SRE book, they use slightly weird terminology. Because when they call it alert, what I would call a page. At SoundCloud, we have like severity labels. I mean, you know, Prometheus, alert manager labels, you can label it whatever you want. And at SoundCloud, we decided we have a severity label, and the severities are critical warning info, right? But like pages is just very explicit. Pages is the thing that wakes you up and makes you curse and whatever. And an alert, for me, an alert, or for Prometheus, an alert is everything that the alert manager handles, or that is an alerting rule on your Prometheus server. So it's all of these. And what they call it tickets, which is a really good one, which most people call email alerts, but email is really the worst possible distribution way, but also the most frequently used. Ideally, it goes to an issue tracker, but this is also part of the alerting story. Yeah, I think where we still have to improve how to do this properly. So tickets are alerts that nobody has to act upon immediately, so you won't wake somebody up, but it needs to be acted upon eventually. And ticketing alerts are alerts that are fine to be cause-based. A server is down. That doesn't bring down your site because you are like you've designed your distributed system in a way that it can tolerate that. But of course, you don't want to have that server sitting there forever, right? It's kind of expensive. So at some point, somebody who goes through the ticket queue should see, we have those 10 servers that are down. Oh, and I think they all have run the same kernel version, so perhaps whatever. Like you might even find some reason and mitigate it in the future. But this is something you just do as your job, but not in the middle of the night. Pages in general should be, if possible, based on symptoms because they will catch more of the outages while they will not have as many noisy false alerts. But causes are also important, what I call informational alerts, and they call it logs. For some reason they call it logs in the SRE book. I mean, logs kind of are also informational, but I think they really mean alerts that essentially say, this parameter is not okay. I don't know if that will be any problem, but this is nice to have this, and I think people should use this more. Like developers in like Prometheus style monitoring are very much in the loop for monitoring because they have to instrument their code. They often have an idea, like if this, whatever, count of things in my code is more than 100, that might not be a problem immediately, but it's weird, right? So you can put an alert in place that says this is weird. So when you get a page, I mean, another anecdote, now Google anecdote, like we had, at Google is not like this whatever, divine being where everything is perfect. We had exactly the same problems that everybody else has like 10 years later. So there was a very complex system, I was on call for that and was paging all the time. Because all the developers thought, okay, if this little job has more than 100 tasks to work on, that's wrong. Page, right? And then you got pages all the time. And then we drank that Kool-Aid of symptom-based alerting, and it was a processing pipeline. The SLO was every single event should go through this pipeline, and eventually, and 99.5% should go through the pipeline within half an hour or something. So clear SLO, put a page on it. So we had 2 pages. Alerts are being, events are being lost, and events take longer than whatever, 30 minutes. So you wake up, events take longer than 30 minutes. And then you look at this, and it was a huge Rube Goldberg contraction. I think it was the most complex system that Google even had back then. You looked at it and were like, okay, and what do I do now? And now you want the old alerts back, right? Where it tells you, okay, this task is actually pretty busy right now, and this task is not as busy as it should be. And this is where like informational alerts really come in handy. So this is all to say that, okay, and I have another slide for that. I'll talk about this. Symptoms are also a bit blurry. The next slide, I think. It's that, yeah. So this is all from the chapter 6. Very nice. One person's symptom is another person's cause, because that's all relative, like everything. If you're just like 5 people company, then of course your symptom is that your users are happy. If I'm a 500 or 5,000 or 50,000 people company, then you probably have like a database team. And for the database team, they have an SLO with everybody else to serve all the MySQL queries within 100 milliseconds or something. And if the database is down, for the database team, they are out of their internal SLO. It's a symptom. But for everybody else, this is a cause. So they might actually be down. They might also have another database replica, or they have the Cassandra database they could fall back to, or they have a graceful degradation mode. So it doesn't necessarily mean they are also down now. It's just a cause for them. And they also should, I mean, ideally the database team gets paged, they fix it, and the other people could just sleep. Whatever, like it's all a bit relative. And then, this is also interesting, because this is what you might forget with the whole SLO thing. Ideally, you detect the errors before they occur. And now that doesn't mean going back to like cause-based alerts, but ideally you have situations like this. Like, let's say your database table is 95% filled before one of the counters goes into overflow. And then you know I add every 10 minutes another item there, and I know I will be out of counter space in a week. Then it's also, I mean, in a week you can still return work hours. But there are problems like that, where you know in an hour I will be down. So of course you should page somebody before you are down. And also the famous, I think I have, yeah, famous n+1 redundancy. So Google had this even back then. They had n+1 redundancy on the level of whole data centers. So if a service is served from 10 different data centers, there must be enough capacity so that the largest data center can go down and every other data center can still serve all the peak traffic. That's called n+1 redundancy. If you are n+0, like that data center has now gone down, then you can perfectly serve the traffic. That was part of the idea, right? The whole data center goes down, you serve all the traffic fine, no user is unhappy, you are totally within SLO. But that could also count as a symptom because your kind of meta SLO is that you want always to have n+1 redundancy because you want to be safe against a whole data center falling into the sea. Nearly full is a different thing. I actually talked about this. It's all a bit like related. Oh, somebody will take care of that. So this is now the thing I wanted to do because Stefan Davidovich, sorry, it's the Czech guy, Davidovich. That was an intern in my team in Dublin, like every important person who worked there. We always called him the intern. He's now a senior staff SRE, which is like kind of one step before God or something. And I also called him, is he now the senior staff intern or something, whatever. Like he also wrote stuff in the Blue Books, and now he wrote like with Betsy Beyer, who also wrote stuff in the Blue Book. They wrote this nice article, kind of warning against this false dichotomy of cause-based alert bad and symptom-based alerts good, because this is what people did then after this Kool-Aid came out that you should just alert on symptoms. But that was never true, right? It's never said this like nobody said that. Because it was about pages should be symptom-based, but you still need cause-based alerts. And this article goes over this, so it's on O'Reilly Ideas or something. You should totally Google this and read it, it's really inspiring. But it's not like, it's a bit like as if everybody did it wrong. At least nobody said what they say somebody said. Okay, now talking about symptoms and causes, there is this weird thing about black box versus white box monitoring. Back then, when Prometheus came out 5 years ago and Nagios was still a thing, I had to explain why people should use Prometheus and not Nagios. And the first dimension of explaining it was that Nagios is like host-based, and this is not like the reality. We are all server-based and clustered and everything. So this is the traditional view of the world. It doesn't fit anymore, and this is the modern world, and Prometheus is service-based monitoring, and Nagios is host-based monitoring. But we also opened up a second dimension, like Nagios is this black box monitoring that was necessary because developers threw everything over the fence, and ops people had to monitor it somehow, so they just sent in an HTTP probe or something, and that's Nagios, right? No changes required to the code. Well, Prometheus, for better or worse, you have to involve the developers to instrument the code, which is what you want to do anyway, because you want also traces and logs and everything like the modern world requires developer to instrument everything, and this is called white box monitoring. But now, black box monitoring for the win. This whole symptom-based alerting sounds like sending like black box probe from the outside is the perfect symptom-based alert, right? You simulate user traffic, you see where it ends up, how long it takes, does it fail? Perfect, right? Now if you read the original SRE book, you think black box monitoring, the unlikely hero of the modern age, but they write something, and that's totally true for everybody who does that. For, where is it? I have a quote. We combine heavy use of white box monitoring with modest but critical uses of black box monitoring. So yes, you should have black box monitoring, and there's also, I think, Prometheus black box exporter, right? So you can totally do black box monitoring with Prometheus. It's just not the first nature. It's like whatever. It's a thing with one additional wrinkle. So there is critical black box monitoring, but most of the monitoring, including the alerting, is done with white box monitoring. So why? So SRE book quote, for not yet occurring but imminent problems, black box monitoring is fairly useless. So this is the thing, right? Ideally, we want to detect problems just before they occur. Like not noisy, but yeah, we want to do that. And white box monitoring is way better. Then you need white box monitoring anyway, because the black box probe are strictly symptom-based, but they don't give you any cause-based insights. And you want to find out what's going wrong, not just that something goes wrong. You want to know how to fix it, right? So you need white box monitoring anyway, and once you have it, you could also base like pages on it. But then there are things that are actually not that prominent in the books. This is kind of more my take, and I find that really important. One is long tail latency and slow burning of error budgets. So you usually have like SLOs, like I want to have 3 nines or 4 nines. So let's say 3 nines, that means if one probe out of 1,000 goes wrong, you are already in breach of your SLO. So that means you need 1,000 probes to even detect that you're out of SLO. And then this is like still like a unique event, so you need 10,000 probes or something. And how many probes do you want to send, right? Which percentage of your service should be just serving black box probes or something? It's kind of, yeah. And also long tail latency. There are like many talks about the importance of tail latency in distributed systems. And if you want the 99.9th percentile latency, you again need like thousands or tens of thousands of probes to measure the tail latency. So that's really bad with black box probes. Then my other favorite example is the viral track on SoundCloud. Like we do black box probing at SoundCloud, and we also use it to find our like quarterly SLO breaches or whatever, but that's really for a long time. So over a quarter, we send ourselves a lot of black box probes, and we can find out at the end of the quarter, how many nines do we have, right? That's fine, but that's like, I don't want to know 3 months later that I had an outage, right? I want to know that immediately. That's why the probes are not good for real-time alerting. But also, they are not the real user traffic. I mean, the probes we do, they open the SoundCloud webpage and click on a track and play it, and if it plays, it's fine, but it's probably just a beep or something. Like, nobody listens to that test track. But if a rap battle goes on and millions of users want to listen to that, and the S3 bucket, like, whatever, overheats, I don't know how that works with Amazon, but it could totally be that the rap battle track is not available while our test track is perfectly available, and everybody is sad, and our availability probes say it's all good. So it's not a real user traffic. So, excuse me. Then there's this sentence from Rob Evershoot, one person's symptom is another person's cause. And that's actually a boon, because that means if you have this multi-layered system, like if I'm the front-end layer and send things to like Frederick's layer, and I'm white box instrumented, I can totally count the errors that Frederick's service is throwing at me, then I'm essentially probing Frederick's service with real user traffic. And the instrumentation and white box monitoring of myself allows me to black box probe his service, right? This is kind of the idea, and I made a little graph. So user traffic hits the front-end service, it's instrumented, monitored with Prometheus, and then you have like a microservice mesh or something, you have multiple backend services, and this service knows exactly, like I've sent this service a gazillion requests and 5 had an error or 5 had high latency or something. So probing with real traffic this is really nice, and then you can nicely implement symptom-based alerting and SLO-based alerting based on this pattern, and that's only possible with white box monitoring of the front-end service. Okay, great. SoundCloud. Alerting on SLOs at SoundCloud. So this is now the real thing. So we need 2 layers, like in this little graph. And of course, microservice architecture, you have gazillions of layers. But of course, for our service level thing, we do our probes with an outside service that we pay to send us probes. If I say we, I mean SoundCloud, it's not me anymore, but anyway. But there's also this kind of pattern where you want white box instrumentation and monitoring, and then you take the first layer, and the first layer where user traffic hits us is just after the CDNs. I mean, the CDNs, they also have their monitoring, they often also use Prometheus, whatever. But for us, what is in our responsibility directly is the first layer. It's called Ampelmann, because we're in Berlin, and that's funny, and the expats like it, and whatever. Also, it makes sense, right? And it's essentially just a bunch of HA proxy servers that are configured in a really smart way. And MR is not here today, but he, you might know him, he wrote last year, long ago, 2017. He wrote an article about this. So it's really nice, kind of simple but very effective how that traffic management is done. And of course it's all monitored with Prometheus. HA proxy exporter is the exporter you use. Very handy. I think they have just added native metrics, but it doesn't work or something. I think it's all single threaded and it has still issues. I mean, this exporter, I mean, it's one additional moving part, but it's super rock solid. Like this
might be also the first exporter, I think. Was one of the first.
It was one of the first because we needed it so heavily, right? So fish was there back in the days, right? And you see super Q is also here. It's like all history. Yeah.
We don't need to use it anymore. HA proxy has a C library for it.
Yeah, we said that, but they are like, we are see he's distracted because I'm just telling stuff he already knows. But anyway, 176 commits, like it's not super active because it's just very robust and stable. Anyway, so you get metrics from HA proxy via the exporter or in the near future from HA proxy directly. And it's called HA proxy backend HTTP responses total. That's one of the counters because HA proxy has this concept of a backend. So they have different backends, they have a name, and of course you put it into a backend label. And this is just like basic PromQL, right? So we call it Ampelmann the job. This is almost all real code from SoundCloud, but like slightly elided if there's like some weird thing in it, but more or less the real thing. So we define all the 500s that HA proxy sees from any of the backends as an arrow. We sum up all the 500s by backend over 5 minutes, and we divide it by everything by backend, and then we get HTTP arrows per response, per backend, by backend, as a rate over 5 minutes. Right? All good? Okay, so Prometheus 101, right? Okay, now what is our SLO, right? I mean, this is all, as we have learned in the introduction talks, this could be anything. This is now also, this chapter 5 is not discussing how to define your SLO, it just assumes your SLO is essentially 99.9% successful responses over the window of a month, more or less, right? And this is also, I mean, this is not our total SLO, but in this context, we do SLO essentially as error. Now, what is an error? If a request times out, it was too slow, it could also be counted as an error. In this case, it's like, we want 0.1% or less 5xx responses that the HA proxy should see from the backends. So now this is the default one, and this is, you can actually in our system define that, because let's say we have API v4, I mean that doesn't really exist, it's just made up, but we have multiple backends with really weird names. So let's say this is the main API at the moment, it has this 3.9 SLO, but then we have a legacy API for some legacy customers, and the requirement is not as tight there, so we are fine with 0.2% errors. Right? Okay. So, now, this is now really easy. We have those recording rules that always record the same number. Now we have it here as a name. We have that recording rule to get our rate over 5 minutes. Now it's easy, right? We just page somebody whenever the rate over 5 minutes is exceeding that threshold on that backend, right? Now you have to say no now. Why is it not right to do that? Ideas? Some idea.
Could it be too late?
No, it's more the other way around. Like you have a rate over 5 minutes. If you have more than 0.1% errors, you get a page. Like you might have 5 minute delay, right? But the problem is, and you said that, an SLO is over a time window. The SLO is not to have less than 0.1% errors at any time. The SLO is that over a month we want to have less than 0.1% of errors. You will always have short error spikes, and then you will have weeks where you have 99.999% availability, right? So I mean, we did this, of course, because we were all naive and thought that obviously we just put this rule into place and then we got paged all the time. Because you always have like 5 minutes of a little error spike. This is the whole idea. Pavel said that as well. You don't want 100% as an SLO. It's way too expensive. And that's exactly the reason. You have kind of an error budget. I think it's like a couple of minutes, 20 minutes or something with 3 nines. you can be essentially completely down, and it's still 3 nines. So you can use that. That is the error budget you can spend. And you want to spend it, for example, to not wake everybody up for every little error spike. So we don't want just look at 5 minutes. That's the first lesson here. Okay, now this chapter kicks in, and the chapter's done really nicely because they also start exactly as we just started with a naive approach, and you see now that doesn't really work. So let's do something else, and then they do something else, and it doesn't work, and they do something else, and they go on and refine that more and more. Like this would take probably 2 hours to go through all of that. So I kind of jumped to the end, but you have already seen how that works, right? There's some obvious approach, and then it doesn't work. So the final approach is approach number 6. I've numbered them. It's the multi-window, multi-burn rate alerts. And at SoundCloud, we also incrementally improved our ways. And I also had some ideas how to do it. And then the book, I had the privilege of reading it before it came out because I was the tech reviewer of that chapter. So I read that and said, yeah, this is exactly my idea. I'm so happy that people actually have done this in production already, so I must not be completely wrong. And then there were also additional ideas that I didn't even think about. And I was so happy, and in the end we essentially implemented almost precisely this final solution. And this is what I want to talk about. So, why? What is multi-window, multi-burn rate? So the first thing is multi-burn rate. Why burn rate? This is now the idea with your monthly error budget. So burn rate of 1, this is the easiest to understand. That means we are burning our error budget at the kind of right rate. If we just keep burning like this, at the end of the month, we will have exactly burned all of our error budget. It means we are always at 0.1% error rate. So now I don't want this, right? I don't want to be at this rate, and then 28 days is fine, and on the 29th day we have a tiny error spike, and then we are out of SLO. Right? That would be bad. So what I do here, if I'm burning at exactly this rate, I want to be alerted if that goes on for 3 days. Why? Because that's 10% of my error budget burned, because the error budget is on a monthly window. I mean, it could be different, depends on the use case. Usually like 3 nines monthly window makes sense for like the general servers. So if I burn for 3 days at exactly the burn rate of my error budget, I have burned 10%, and then somebody should do something. Which is a ticket because it lasts for 3 days, so I can't really blame that somebody has to, in the middle of the night, get up and solve the problem in 5 minutes. Fine, right? So now I go up, like you can pick any numbers, this is what they did in the book, and that kind of makes sense. So if you burn at 6 times that rate, that means after 6 hours you have burned 5%. You can do the math, but it's true. I did the math, just to make sure it's right. So that means in 6 hours I've burned 5% of my error budget. That's kind of bad. If this goes on like that, I will have burned all my error budget pretty soon. So this is kind of the first time where I want to page somebody. And the really nasty thing is, this is a weird factor, but if you look at it, if you have 14.4 times your burn rate, for 1 hour you have burned 2% of your error budget, which is again a nice even number. So this is something where you definitely want to page. So this is directly from the chapters, not from SoundCloud codebase, and this is so nice because the Googlers saw that everybody else is using Prometheus, so they use PromQL to express those alerts. So this is directly from the book, and this is 2 alerts, one that is page, one is ticket, and they have a slightly different recording rule, but they have one over 1 hour, one over 6 hours, and one over 3 days. Like really long ranges here. And this is 0.01, is now not a percentage, it's just the ratio is still 0.1%, right? So if it goes over 14.4% of that, 14.4 times, then you get a page, or the 6 hour thing is 6 times, or the 3 day thing is exactly there, then you get a ticket. Very straightforward, right? So that works quite well. Now there's one thing that is kind of counterintuitive. You already said the page is too slow, right? Because you saw the 5 minute. Now even the most severe page has a 1 hour time window, right? This is the recording rule, but it's rate, and then in square brackets 1 hour. So how can this even be fast enough, ever, right? And this is the graph that solves that problem. So this is the actual error rate that you have at the moment. And this is the detection time depending on which alert is firing. So of course, if you have only 2%, this is here the target thing, right? If you have exactly 2% error rate, 14.4 times your error budget allowed burn rate, then it takes exactly an hour. This is where the hour happens. But if you have a complete site outage, every single request is an error, it takes 1 minute. And you can do the math. 59 minutes of 100% availability and 1 minute of 0% availability is 14.4 times 0.1%. This is the one thing that you don't think about it naively initially. Even if you have a 1 hour rate, if you have a 100% outage, it's still very quick that you reach those thresholds. So this alert will page within a minute if you have a 100% site outage. And then of course, the fewer errors you have, it goes up and up. And this is the 2% error rate where the one alert will never fire. Then the other one, the 6-hour window, takes over, which takes longer to detect things until it reaches the 6-hour threshold. And then the ticket takes over, which is, yeah, I mean, this is the area where you still want to do something because you really slowly burn your error budget, but you have time until work hours. This is kind of one of the very important graphs. And it's directly from the chapter, completely stolen. And this is the other important graph. Because there's still one problem. This is, by the way, it's kind of approach number 5. Now we are getting in the multi-window thing in approach number 6. And this was also something we ran into when we experimented even before the book chapter was out at SoundCloud, and we kind of couldn't solve it. But this is so easy but ingenious. So I'll play through this scenario here. The blue line, this is also blue line, here you see it. Right? This is the actual reality, right? So you have 0% error rate, or 0.1 or something, very low. Then an outage happens, you jump up to 15% error rate, it's all logarithmic, 15%. And then after 10 more minutes, the outage is over, and you will jump back to essentially no errors. So now let's look at the red line. The red line is the 60-minute or 1 hour error rate. And as predicted, I mean, this is not a 100% outage, but as predicted, it goes up and up and up. And after 4 minutes or so, it hits the threshold, which is totally fine because you probably need 5 minutes to wake up. And I mean, I guess the story here is that an engineer gets woken up, whatever, laptop has to be woken up and probably fails and whatever. And then after 5 more minutes, issue is solved, error rate goes down. Great, right? So now, so far, so good, right? So the problem is, this is a 1 hour window, and that's also the problem we ran into. So as long as you have this error spike in the 1 hour window, your alert will still continue to fire. Fire, 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 and after an hour, it drops out of that window and it goes off. Now, where's the problem? I mean, who's using PagerDuty? Man, most people are using PagerDuty, right? Semantics is, by default, you can configure all of that. You ack a page, and then it will keep it acked for 24 hours. So, I mean, no problem. The page fires on, you ack it for 24 hours, you go back to bed, right? No harm done. You have to protest again. What's the harm? That's possibly done. Let's imagine at t plus 40 minutes, we have the same thing again. Jumps up again, same alert, it's still firing, will also fire, but you have acted for 24 hours. So you won't get woken up again. And then you go out of business or something, because for 24 hours you will not notice that your site is down. So bad, right? You want something I think they call it a reset time in the chapter. You want the alert to reset quickly. I mean, you want it to fire quickly if a real outage occurs, but you also want it to reset quickly when the outage is over. And this 1 hour window is exactly this problem. And this is also why we shied away initially from that, but there's a very simple way to solve that. So we go back to our 5-minute error rate, which we declared as way too noisy. This is the green line, right? So it shoots up the moment you have error rates. And let's imagine this was a very short peak. It would have paged you if your alert were based on that. And then the outage is over and it very quickly drops down after 5 minutes, essentially. So what we want the best of both worlds, right? There's a Boolean operation for that in PromQL, which is AND, right? So you just AND both alerts. So what happens is now, outage starts, it could be just a peak, right? Nobody gets paged, but after 5 minutes, the 1 hour thing is here and the green one is here, so both are firing, and that's the moment where you page somebody. And if you're here, the green line is down, orange is still up, but this is where the alert stops firing. So this is when you're done. You don't, so what do you do in PagerDuty? This is very important, many people don't know that. I had to teach SoundClouders. You never just act. If the outage is over, you go to the alert and say resolve. Because that means if the alert happens again, PagerDuty will page you again. Luckily, the alert manager will actually do this for you if this works out like this. Like PagerDuty will declare this as auto-resolve. But even if not, you think it's not firing anymore, always remember, make sure that those alerts are not still act. To actually get it out of PagerDuty, and if it happens again, you get paged again. So this is this simple but ingenious idea. You just have, this is the valid where it's called multi-window. You have a short window and a long window, and you add it together. And then you get like blissful alerting. So now this is again almost verbatim from SoundCloud code base. And we did every burn rate thing separately for reasons I will explain. So this is the 14.4 times thing. This is the alert rule as you've seen them on the slide. So it's also nice YAML indentation thing, so you can do perfect Brazilian style indentation. Which there's a GSOC project to do this automatically. This year it will happen. So here's our rate over 1 hour with the threshold, right? The normal threshold configured times 40.4. In the other alerts it's times 6 times 1. And here's the 5-minute rate with the threshold, and here's the end, right? Now there's a for clause, we'll talk about this in a second, that's explicitly banned in the chapter. And as the reviewer told them they should not do that, they added a little note, but it's not very comprehensive, so I'll explain that. So we have a system label at SoundCloud, which is the universal label. Every system has a system label at SoundCloud. I pretend it's just the backend. In reality, it's more complicated because whatever. In reality, there's a label replace here to cut out the system label from the backend label. But like Kubernetes can also freely label, so we have a system label on every Kubernetes pod. So this is like everywhere, and we use it for alert routing. I'll explain that also in a second. This is critical. We get the window of 1 hour in a label as well, and we have nice annotations. A backend burns this error budget very fast. Backend, whatever it is, has returned percent 5xx, and we also, of course, have a runbook link because I'm a great fan of runbooks. This is, and then you get it for all the other things. This is our table, so we have a 1 hour 5 minute, a 6 hour 30 minute, and then a ticket 1 day 2 hours, 3 days 6 hours. And this is the burn rate factor. This is the error budget consumed the moment you get the alert. And I mean, I put this all into place, I think, a month before I left. And I haven't heard nothing, I haven't heard anything bad. So I hope this all works perfectly. So now the fourth thing. Yeah, in the workbook. They write you should, essentially they write you should never use for clauses. They also explore for clauses in this iterative process. They say for clauses essentially delay the time until you get the alert. We had very long for clauses because initially we thought this is the reason to get, like the way to get over the noisy thing with the 5-minute rate. That's not true, you should not do this. So there is a reason why we have for clauses, and they mention it slightly because I told them to, but yeah. The reason is statistics. So error rate or SLOs are usually, of all those requests you've served in the month, you want to successfully serve 99.9%. It's not of all the minutes in a month you want to have served successfully in 99.9% of the minutes. So if you have a lot of requests, you are allowed to have more errors. If you have very few requests, you're not allowed to have that many errors, but it's all like over the month, like it's more complicated if you go deeper into it. So now the problem is, you just launch a new service. Or you have multiple data centers and you first time send traffic to a new data center. Caches warm up, let's say the first 10 requests have like 1 request that goes wrong. It's totally fine, right? Why should we get alerted on that? But even if you have like a 6-hour window, and the whole 6-hour window just has 10 requests in the very end there, and one of them is failed, it's a 10% error rate, and all those alerts like, they light up and everybody gets paged the moment you unrain the traffic, right? This is not what you want. And of course you can do really nice statistics on this and analyze this, but this is a really like very simple way of saying, okay, I want this alert to fire for at least 2 minutes. I mean, the reaction time is usually like 3-4 minutes. even with a full site outage, and the person who gets the page needs 5 minutes, so we can totally add 2 minutes. And then at least we have 2 minutes of like statistics. It's not perfect, it's not clean, but it's very simple, and it helps a lot to not have those like drain, undrain, switch on, switch off, weird alerts. So this is my take on that. Worked quite good. And the last thing is just who gets the page. For Prometheus people, that's kind of very logical. There's the system label I talked about. And then this is, everybody can find their own solution for that. But at SoundCloud, we have an alerting tree that looks like this, which is like crazy. And SoundCloud is just like 100 engineers. So now imagine how this looks in like a 10,000 engineer company or 350, whatever those acquisitions were they end up. So what we have, this is the alert manager config. This is not written by humans. So we just have one JSON file where we put for every system the owning team in it. And then we have a file where it's defined that every team has this PagerDuty account, has this Slack channel. And from that, we just auto-generate with Chef this humongous config file. So your API team has like an API team 1 receiver that receives all the alerts that has system API v4. If it also has the security critical label, it will be a page. API team crit is configured to go to PagerDuty. And if it also has the info label, then it goes to API team info, which is a receiver that goes nowhere. You can just go to Alert Manager and look at pages your team got that were not sent anywhere for like diagnosis. And I think that's it. So this is the link to the blog post. This is a link to my like talks file in the GitHub repo where you can see the slides. And that's it. Thank you. Perfectly on time.
Also the sky.
The sky lights up. Error budget consumed. Rain budget. Okay, I think now we have a break, right? Or should we like questions? Or
yeah, we can do questions.
if you have something burning, otherwise you can ask me over bagels. There's something.
Did you have like a rule of thumb how you calculated the short window and the 4 times, or is it more like?
So this is just directly the numbers. I mean, we did some stumbling around before the chapter came out, but especially because we weren't thinking about this reset trick with the end. It was kind of, yeah, we have to think about it more before we put this into production. They have a bit of science behind it, and they also say if you have like a radically different thing, like your windows, not monthly, but weekly or something, it really depends on the kind of service, or you have 5 nines and not 3, it might be different. They discussed this a bit. It's semi-rocket science. Like it's something behind it, but it's also, I think the most important thing is just you have like 3 wildly different pockets. So, I mean, that's enough, right, to have this. Ideally, it would be all like a soft transition with an infinite number of pockets, but you don't really need that. I think the most important thing is have one that is really nicely suited to your critical alerts and have one that works with like slow error budget and then have one in between and then you're good. And those numbers are like, yeah, they kind of work in normal scenarios. But there's a bit of theory behind it why they pick exactly those. And we just copy.